Thank you very much, Ashutosh, for many things. Thanks first for inviting me at the last minute so that it doesn't give me much time to really put together whatever I wanted to say. So the blame of not giving a good talk rests on Ashutosh. That is the first message. Second, Ashutosh is also settling scores. Why? Because when I was president, I invited him as a DST secretary to grace the occasion for some award function, and that entitles him to invite me, and now I'm reciprocating. So one is to one. And the third reason is I'm truly excited to be amongst you on the 90th birthday. I think this institute has been a pillar for a long time for anchoring the science policies, though not saying policies, but affecting it without saying it, in terms of charting the course, in terms of interacting with the international organizations like ICSU, now it's called ISU, and connecting to different academies in the world. So this is really a gateway for connecting Indian science to global science. So it's a great pleasure. And when Ashutosh asked me, I gave this title, which is a slightly different version of a talk I had given, but with different content, where I thought people always ask me as if I am a born bureaucrat, which in Delhi it's difficult to dispel. But then one has to keep in mind that we come from science domain, and science is of paramount importance in logical thinking, and that logical thinking leads to the right policies. So there is no big mystery here that how we can seamlessly go from doing basic science, fundamental science, applied science to the policy domain, because policy, I will just show you, without that it will be bit just putting a overlayer, not really going into the depth. So my experience for the last 49 years in science helped me to really navigate this new role, which I'll just tell you what it is. Okay, so this I just thought I'll take a minute of where I come from. I did MSc in 72, which makes it 52 year of experience. Joined BARC and then went to Kalpakam, and I was there for almost 14 years. And in between, I got my PhD from ISC and went to postdoc in Stuttgart, came back, moved to ISC Bangalore because I wanted to teach. That is a great passion for me, and set up the lab from scratch using Raman spectroscopy, ultra fast spectroscopy, and more vigorously rather on soft matter. That's where Ashutosh and I overlap in our interests. So for youngster who don't know much of soft science, can Google it, what is soft matter. This is matter where you really talk at a larger length scales like colloids, polymers, biomembranes, all those are clubbed under soft matter. And how they flow is a big subject in itself, connecting from the chemical engineering to chemistry to physics or material science. And more recently, my interest has been in active matter, which mimics life. And still more recently, is stochastic thermodynamics. Thermodynamics, which you all know. Now, what is stochastic? I'll tell you. What it means in one or two words is thermodynamics, you deal with bulk system, 10 to the power 23 atoms per cc, right? Avogadro number. Here, when your number reduced to few, 2, 3, 5 particles, can you still talk of thermodynamics? Answer is no. You can, because the fluctuations in the mean of those pressure, temperature, they will be so huge comparable to the mean. So you talk of fluctuating quantities. So the whole subject has now come up called stochastic thermodynamics in the last 10 to 15 years. And it has very, very fascinating outcomes, which I'll tell you one aspect of it. So stochastic thermodynamics is what we have been dealing with. So I'll tell you only one problem. The limitation of time and your patience tells me that I should not go overboard on encashing all the goodwill of Ashutosh. I'll take 25 minutes on this and maybe 20 minutes on the second part, how they connected. So I'll take one example of a heat engine which many of you read in PSA. Now this you know what is the meaning of heat engine. You have a piston and a cylinder. You connect it to the heat bath and you have a cyclic hot and cold gas temperature varying and you get the useful work. This is the paradigm of heat engines for the last 285 years since Carnot time. It has not changed. Now in that there is a very fundamental, there is a understanding which I want to pose, and it is almost thought that is a theorem, but there is no such theorem. This is and I'll tell you only one problem out of that. So what is a heat engine? This is the Carnot cycle where you plot pressure and volume of the gas. So when you have gas, you compress it in the cylinder at a high temperature. This is called isothermal compression. At low temperature, you heat it. This is the adiabatic heating. At high temperature, the piston comes out. That's the time you connect a flywheel. All your modern day gadgets are linked to that. So in this part, you get a useful work done and you repeat this at some cycle. So that's when you have to define what is the speed of my engine. Because when you talk of a car, you will have to define what is the speed of my engine. Now this was done by Carnot in 1824. He died very young. You can see he died very young. 1824 he gave this based on his work, the laws of thermodynamics were later made 8 years later. So it's a very different situation of when we say linear innovation. The fundamental laws of thermodynamics did not come before, and scientists said, oh, I know first and second law, now I'll make a heat engine. That's how we think. It came much before that, and based on that success, actually first and second law of thermodynamics were formulated. So it's a very interesting example of a reverse innovation cycle. So this is what I told you, and you can get the efficiency, which is high school material, 1 minus T cold bath, T hot, and this is true only in the reversible case, which means the engine is extremely slow. Only then you can get Carnot efficiency. I am sure some of you would have heard this word. The more simpler engine is called the Stirling heat engine, which is similar but little simpler. Here you have a isothermal expansion at a high temperature where you get the useful work. Then at this point, when the piston has come out fully, you cool the gas. It's called isochoric cooling, same volume, don't change the volume. Then you have isothermal compression. In this you don't get the useful work, and then you have isochoric heating. But the net result is if you do it at a certain speed, you get the work done, and all your modern life depends on this engine. And this gets slightly modified from Carnot because this is not the adiabatic thing, and this is related to volume and all. I don't want you to worry about it. This is a macroscopic limit where the working substance is a gas, 10 raised to power 23 atoms per cc, bulk gas. Now there is a concept of a nano heat engine which was said. So people started asking when this nanoscience was coming up, can you make a heat engine at a nano scale? Which means instead of big gas piston, you can work with one atom or one colloidal particle. Can you do it? Conceptually, it was completely a breakthrough. Nobody thought it could be possible. So there was a theoretical paper which said it is possible, and he gave a construct. So what they said was that you have to remember it is not just miniaturizing the heat engine, not the piston cylinder, but when you have only one particle in a heat engine, the fluctuations in all this pressure, temperature, they will be huge because there is nothing thermodynamics about it. But that's how the stochastic thermodynamics came, entropy, all those concepts were developed, and they said it is possible if you do the following. And the experiment is very interesting, theoretical experiment. You trap a particle not mechanically but in a laser field. It's called a optical tweezer, and that laser intensity decides whether it is very tightly held or whether it is loose. So this is expansion and contraction, expansion, contraction, and whole thing is in a temperature bath. So the bath temperature can be high, low, high, low. So experiment is very simple in concept, and this was translated, a theory was given in actual practice from a Stuttgart group in 2012 or something, where they made this heat engine after 5 years of work. The reason I know 5 years, I'll tell you, it's an anecdote. I met this person, Professor Clemens, and we had published many years later a heat engine made out of bacterial bath, which came in Nature Physics, and he was very happy because he must have been the reviewer. So he said, how many years your student took to make this bacterial heat engine? I said, maybe 3. He said, oh, you are so lucky. This student took more than 5, and after that he left physics. Because he thought if physics is doing 5 years one experiment, it can't be his life. So it's a tough experiment, but anyway it can be done. So they made a heat engine, showed how the work can be calculated from those equations, and how the power and all that. This is what I'll come back in a minute to you. And then the Carnot engine was made very recently. Now, what is the equation? I don't want you to read at all. What you have is the particle in a well. Particle moves, right, at a given temperature. That you measure, that's all. The position of the particle as a function of time. Don't do anything else. Put a camera, digitize it. If you do that, then you know particle position, you know velocity. Using that, you can simply do high school physics. What is the work done? What is the heat? And you can just put that in. And what else you need to know? How stiff is the potential? What is the force constant, right? Spring. You know that quantitatively. Put that, because you have to change K when you are expanding or contracting. So this you also know completely mathematically and whatever experiment. All that you put, and you can calculate these quantities, and a function of every cycle. And lo and behold, it does work. You can show that it is a finite work, and that work also follows, it so happens, macroscopic equations, even though with one particle, which was a big surprise. In stochastic thermodynamics, they did that. Now, this is the 284-year-old puzzle I want to talk to you. Now, there is a cycle time. I told you Carnot efficiency is only possible when it is done extremely slowly. So, you plot the cycle time, and this is the time when you will get the maximum work done, correct? Because everything is reversible, everything gets work done. But as you make it faster, which means smaller cycle time, it decreases, and below that it's not even a heat engine, it becomes a refrigerator. And efficiency, which is work done divided by what? Heat, is the efficiency, which is also maximum at the largest time. But there is a big price to pay. What is that price? That price is power. You don't need work, you need power, because that's how you need to make your life worth it. That time power will be zero, because power is work by time. Time is infinite, power will be zero. Though you have the maximum efficiency, you have the maximum work done, but it is a useless thing because the power is zero. So what human beings have done, they have found out there is an optimal time because here it is power is 0, here it is 0, in between has to be maximum, simple law. That time all the engines in the world work at this cycle time. So for a given engine there will be an optimum speed. At that time the efficiency will not be the Carnot efficiency, but it will be slightly less. So this is what I call power efficiency trade-off. You get finite maximum power, but you trade off the efficiency. So this is the paradigm for the last 285 years, and it was thought that you can never, looking at it, we said what should we do to overcome this 285-year-old paradigm, because we went through the literature right from history of the science. There is no, we don't have to sacrifice, right? That is the one. Now the minimum time is already decided. What is the, now how do you know it is the infinite time? You look at all the processes in your engine. Time larger than that is the quasi-static, right? It's the infinite time. But how can we reduce this so that we still get the efficiency? Which means we have to reduce the cycle time. Can we reduce it? Question. Now this is something which has not been answered. So what happened when we were worrying about it, there are 5 theoretical constructs which have been published on overcoming this paradigm. All these 4 of them are completely theoretical. They write the Hamiltonian, they write everything, and they said if you do this, maybe it is possible, but it is not possible to translate into experiment. This paper, when we were worrying about it, we thought it has something. It is again on quantum system, making a heat engine out of a quantum system, not classical system. But it had a very, very deep line thinking. It said if you can bring system bath interaction, which means your engine and the reservoir, which is the gas, hot temperature, if you can bring this coupling, right now they are independent. At a finite temperature it works, there is nothing, no coupling. If you can bring this coupling, they showed for quantum system it is possible. So we took that line alone and we said let's see how can we translate into action for a classical heat. Ours is classical heat engine. And this is how this paper came out a few years, 2 years back, 1.5 years back. So what we want to now do, bring this interaction. How do we bring? Please look at what is our heat engine. Our heat engine is, this is the heat engine because this is the potential well. This potential well means some spring constant, right? Expansion, contraction. If that and the temperature of the bath can be not independent but connected to each other, we can get engine reservoir interaction. That's the point. If you can take this message, I think the talk is over. This is what we wanted to implement. Now how do we do? In the experiments we had done and the German group had done, the temperature of the bath was a big volume which is heated or cooled by a heater. Now that you cannot control. So we wanted another way to have an effective temperature, not like this physical heater and switching on and off. So this is where we came in with a very, very nice thing which was which is very interesting. You take this particle which is trapped, put 2 plates, copper plates, and apply voltage, electric voltage, random, with some zero mean, with some statistics, and control the magnitude of this, whether you apply 1 volt, 2 volt, all that. If you do that, and then you can show very easily, the effective temperature felt by this will be much higher and it will depend on the magnitude of this voltage. That's the bottom line. Outside bath temperature is still 295 Kelvin, but the temperature felt by this is controlled by electrical noise. So electrical noise is now a control to do the temperature, and now we said, can this temperature this effective temperature depend on the system, which means spring constant K. That's the point. And answer is yes. I will again not go into detail. This is something we can discuss. Answer is yes. If your force constant is below some value, we can prove that. Once you do that, we showed you can make a heat engine where the probability distribution you can show as if it's at a high temperature. All that you can verify. The effective temperature is not 295. You can get any temperature you want. Water will boil at 100 degrees centigrade. But the effective temperature of this can be as high as 1500 degrees centigrade. This is just by electrical voltage. But what we showed, I will again not go into, this is the key figure. For the fixed electrical noise, depending on what is your K, the effective temperature changes. Which means it can vary from 470 to almost 1000 depending on K. This is the most unexpected result. If you are at a very high K, nothing happens, which people knew for 20 years. But at low K, which was not explored because this concept was not there, we showed that T and K are coupled. And this coupling can be destroyed by putting some salt, particle, all that test we did. Don't worry about it. Bottom line is engine and reservoir can be coupled and there is a definite relationship. Now I'll give you the main result. This was the Stirling cycle when the cycle time is 50 seconds, very large, nothing is surprise. You get all theoretical computed experiment. This is the final result. I just want to take a minute. Look at the work done. This is the limit predicted by theory and it agrees. It comes down as expected. But now at this time something starts happening. So this should have gone down. It didn't go down because of this coupling, which again I will not explain in detail. This is something was totally unexpected. At the shortest time, few milliseconds, it is very, very high. And if you look at efficiency, again starts coming down, but below this, which has a physical meaning, which I didn't explain, this again goes up and this meets the Carnot value. So at low tau, you start happening something new physics coming in which overcomes this thing. So this is the snapshot. Power is of course very low at large tau, which is expected. Now here it starts coming down. This is the one which is optimal, people know. But in this heat engine, it goes up. And you can see huge change, almost a factor of 100. So what is happening is, and the efficiency again reaches the Carnot efficiency. So what is happening is you can make heat engine extremely fast, still get the work done and still get the Carnot efficiency. And this is what we said, you can overcome the paradigm, overcome this huge mental block which was there. Now why it happens, again I will have to seek your forgiveness. What we have shown is actually with this electric noise you can get faster equilibration. If this noise was not there, it would have taken 270 milliseconds. But because of tinkering with this noise, it only takes 12 milliseconds. So we played with the relaxation time. That's the major point. And this we could explain, and the physics is that when you have a potential and you apply a voltage plus minus, particle will move towards positive side. Earlier it was all doing diffusion, random. Now we give it a directed motion. That directed motion helps it to equilibrate. It kicks it. Come on, get to the equilibrium, and does that. And this was the major point. And this is where we asked, if this is the physics, can we have another system where can bring the directed equilibration and still overcome this efficiency power trade-off? Can it be? And we showed recently, this is the Rajesh work with student Niloy, that instead of water, we put a gel like a soap solution, and that soap solution behaves like a solid at smaller time, like a liquid at larger time, which you know there are many examples that if you have some gels, I don't know if you are worried about the shampoos, you try to put in a different way, depending on how you rub it, the viscosity will change. So that's how we did that. It is a gel solution, and we wanted to know when we go to larger frequency of this gel, actually it starts becoming like a solid. What happens when it is becoming like a solid? When it becomes like a solid, the medium, it will have elasticity. So elasticity will ask it to come back, not a diffusive motion. And this is exactly what we showed, and I will not go into detail. This is another way to control temperature using lasers. Let me not give you the details. We made a heat engine and we showed that work done does not come down, actually it again goes up at smaller time. So we can again have this paradigm broken. So the temperature here is varied in a very, very nice manner. This is Rajesh's discovery. Instead of electric noise, you put another laser which can kick in, and controlling the second laser can get any temperature you want with any statistics. So this is what I called a photon phantom, which we used to make this temperature, and we can show that it overcomes this. So let me not go into the detail. Just to summarize this part before I come to Vigyan Bhawan. What's the time? Because time? Right? Time is right. Okay. So I thought I'll just summarize this first part. Engine bath interaction, I told you, this is the key part which can overcome this trade-off. Reservoir engineering by the photon phantom allows another tuning of reservoir, and so on. Now, biggest question here is, how do you get useful work for getting something out of it? This is a heat engine, we know, but people always ask me, can you connect a flywheel? How do I know it's going to do work for a real life situation? So this will be a nano thing which we'll have to do, and this is the work which is going on right now, and we have shown that you can connect some cargo and it can drive the cargo. So that is the work which I will not talk about. So these are some other things related to what I said. We used bacterial heat bath, we used coupled. Now can you couple these heat engines like in a, you say 4-stroke, can you make 4 heat engines, can you couple them? And we showed when you couple them, you don't get 1 plus 1. Actually you get 1 plus 1 is equal to 4. Much more work and much more efficiency, again for a very exciting reason of non-equilibrium statistics. Okay, second part now. And this is something I moved to Delhi on April 25th, 2022. And again I have to thank Dreamscape AI tool for these things. So what I did, I said a scientist moves from lab to science policy. Vigyan Bhawan, what will it do? And I don't think it is so bad. This is not the AI picture. This is the AI picture. And this is the AI picture. So it also tells the youngsters the power of AI. You have to use it correctly. I use this for amusement, but you use for better purposes. And don't write papers using AI. Because now we have a tool which can detect AI generated turn it in for plagiarism. Now there are many tools. If you can give it, it will tell you whether it is machine generated or human beings. So let me out. So this is something I thought I'll mention what this office is all about. So before me was Dr. Vijay. He served for 4 years. And before me was Dr. R. Chidambaram, whose photo I'll show just now, who passed away 3 days back. He was the second principal scientific advisor, and the first one was Dr. Kalam. He served for 2 years. So I am the fourth one. But so the roles of Office of PSA has evolved over a period of time, and in the last few years, this is an instrument of science advice shaping policy choices. Now, we have two instruments in our office which we use all the time. One is a Prime Minister's Science, Technology and Innovation Advisory Council, where we have 6 members plus many secretaries who are members, who are invitees. And the other one is again a very important aspect called Empowered Technology Group. So all the technologies which are being bought in government sector, including strategic sector, or before they go to cabinet, they come to our office for knowing it is the latest technology or is it a old technology which is being siphoned off to India and so on. So we do our due diligence with experts, and this is what this does. I'll tell you a little bit of this today, what this has done, and this is related to again formulating the right missions at the right time to know what India should be doing as a whole, and what are the instruments needed for that. So that's what I thought in next 20 minutes I'll tell you. So here there are many technologies which are needed for any nation, and this is not a complete slide. I just indicated few of them: quantum technologies, advanced communication technologies, 5G, 6G, Open RAN, digital transformation where India has taken a lead, AI, cyber security related, biomanufacturing, biosecurity, One Health, clean energy technologies, completely essential, and advanced space technologies, and many more. And the policy cell in INSA is now, which has come up, again can play a very decisive role in contributing to this policy domain. Now, in this PM strike in the last 5 years, many missions have come out which have been launched. So the way it works is PM strike debates on the need for a mission. If there is a consensus that there is enough merit in this, then the right ministry is helped to make a cabinet note, because you need resources, you need funds, and funds can only be given to a ministry, not to our office. That's a good news, because we don't deal with the implementation. We only come in the space where the policy is to be made and empowering mechanisms have to be put in place. Once you do that, many missions have come out. Deep Ocean Mission run by Ministry of Earth Sciences, Natural Language Translation Mission, MIGHTY, AI is now a few months back, MIGHTY has rolled out. Waste to Wealth, our office was running another mission. National Electric Mobility Mission, Green Hydrogen Mission again came out of discussions in the PM strike, and more recently National Research Foundation, another mechanism to support science and technology, has come up. Again it has a history. It came in PM strike and then subsequently it was discussed. So more recent missions in this is the quantum mission and One Health mission. I'll just say a word or two. And one in the pipeline is National Livelihood Mission, which means how the livelihood of people in villages can be influenced in a positive way by technology. That's the mission. And so let me just say One Health, for example. Many of you may be wondering what One Health is. Now, One Health is what you dealt with in COVID. COVID told us that human health, animal health and environment are not separate. They are interconnected because it transfers from there. Which means that if you want a holistic answer, you have to deal with all three. And that is the meaning of One Health. And this 11 ministries are involved and state departments. So it's a Herculean task to bring all of them together, because all of them are doing something or the other on One Health. It's not that it is a new subject. But we want to tell what are the gaps in this connection, and that is all that is a part of this. So it is having an integrated disease surveillance, strengthening routine prevention program, joint outbreak response, and pandemic preparedness for future if it happens. So already this has been rolled out, it has been approved by the cabinet, and ICMR is the leading agency. Now, first thing which we have done in the last few months, just to get you a sense, we have 25 BSL-3 and BSL-4 labs. BSL-4 are only 2 right now, others are coming under construction. But each department had their BSL labs. So under this mission, all these labs will work together, and depending on the nearness, which is BSL lab closer by, they will have access. So this has been done. Second, another mock exercise was done called some Hindi name, a nice name is there, which was a mock drill for a pandemic. Supposing if it breaks out, what will you do? Are we prepared? So that we did about few months back, and from there we learned where the gaps are. So all this is now going on. So our office led it, and now still involved in a very major way. So many technologies are needed which are being done. National Quantum Mission, obviously all of you must have heard, already rolled out, and all these 4 are the components. But some of those who may not be up on it, I'll just make one slide, present it to you. Why do we need quantum? Do people know here why do you need quantum technologies? You have classical computers, right, in your lab phone. Why do we need quantum computers? So I'll just give you one so that you get shaken up and vouch for it. Because all your transactions are based on some security protocol. That security protocol is, for example, it is 128-bit AES, asymmetric block cipher based. All your transaction on WhatsApp and all, when you see a message, it is encrypted, it will say. It will also say it is 128 or 256. What is this actually? It is based on factorization of a number. So a very large number cannot be factorized so easily. 21 you can factor, right? 3 into 7, anyone can factor. But if it is a large number, it will take, for example, age of the universe to factor it. You cannot factor if it is a 2048-bit RSA, which means you are safe. But not now. Now, if you have a quantum computer with 4000 qubits and 1000 million gates, we are not closer to it, but we are proceeding towards that. This will happen, there is a prediction by 2030. This impossible encryption will be broken up in just 10 seconds. So all your financial transactions will be compromised. All your health data will be compromised. So it's a huge challenge for every country to safeguard it. So what people are doing, our adversaries, they are storing our information and they will analyze later when quantum computers come. Store now, harvest later. That's the one. Or harvest now or do it later. This is already happening actually. It's not a science fiction anymore. So all the countries are going on quantum computing mission. India has also launched a quantum computing, and it is so fundamentally strategic importance that I don't know if you have read 2 months back, US has put a complete ban on all technologies related to quantum computing. You cannot buy even a chip. Even a single photon detector you cannot buy, which is used in quantum computers now. So it's a big challenge for our country or any other country to be self-sufficient in quantum technologies, and that's how the mission has come. So it is going on. A mission has been launched, and many things you can see the Google on Google, a lot of description is there, you can go. Last part on this, I'll tell you about ANRF. This is the National Research Foundation. Anusandhan National Research Foundation. It is another mechanism of synergizing the R&D in the entire country without touching the existing funding mechanisms. DST, DBT, CSIR, DRDO, agriculture, they all have their funding mechanisms. They will continue. This is over and above that, but with a broad umbrella of many more responsibilities. And Honorable Prime Minister chairs the governing board, and the Executive Council is chaired by PSA. And there it has all the goals which you can read, which is not very surprising, that we want to put in more resources and more structure and more ease of doing things, so that this S&T ecosystem along with innovation can be strengthened. So here the industries also are included, startups are included, and so on. So this is the new experiment which has been started. So this is the, if you look at the ecosystem of India, you have all the science ministries. All of them have their science programs, engineering programs. ANRF is coming over and above that, and it will connect to, there is another, I don't know how many of you are following, a new incentive has been announced by the government. 1 lakh crore corpus has been created for R&D in private sector. This will be rolled out anytime because the work is in progress to see the structure of it. It will go to cabinet soon. And this is, all these things together will be really supporting the research and technology and innovation. And this is over and above all the mission programs which are going on. So there is no dilution of any of the programs, which people get often confused, and this is over and above that. So I thought I should mention it. This already, these are the goals. Some of it has been launched already. Just to give you one feel, as of last week, there is a program called PAIR. Have you heard of PAIR? So PAIR is partnering top research institutes with institutes who are not doing so well in research in let's say universities and other departments. And this pairing will be a joint funding where 70% of the funding will go to the spokes, which are in tier 2 and tier 3, and only 30% will go to tier 1 on contemporary themes. So this has been rolled out. It has a huge game changing once we put in place. So I will not go into detail. So at this stage, I have 10 minutes. Okay. So at this stage, I just thought I'll also give you 2 examples of what our office does. It's not only we tell others do and we sit at home nicely. So we also are trying to add to the ecosystem how we can synergize. So I'll tell you only 2 programs out of many. One is called RUTA, which is a Rural Technology Application Group, and another is called Manthan. These 2 will have some connection to some of you here. So I thought you may like to know some of it. So what is RUTA? Oh, first I am telling Manthan, sorry. So Manthan is, I don't know, can I have a very loose language to speak? Not in this, somewhat. Only. So this is equivalent of Shadi.com. That's the analogy. Which means you have demand side who needs bride and bridegroom, this thing. There is a supply side, they have the this thing. So demand and supply we want to match, which is exactly what funding agencies do, because they have certain objectives. They give funds for objectives to be achieved. So what is, so demand side will be industries. They will have some problem to be solved. They have some technical problems. It will be international partners like Bill Gates, Melinda Foundation. They have given central line ministries. So many line ministries have technical problems and they do not know which university to go to solve it. Supply side, we will have educational institutes, R&D labs, all CSIR, DAE labs, startups, we will have incubators, all those things are there. How do we match them now? So there is a platform which is completely transparent and very, very safe, where people can load exactly what they want, and we have the supply side where we have listed the capabilities of each one, and there the handshake is done electronically, not by us, and there they do the matching. And good news is this was launched about 3 years back on 22nd August 2022 after I joined. So this already has done 780 opportunities shaken hands, which means 1321 crore rupees have crossed hands already, and 8,000 crore is our expectation, which are in the pipeline. So what I want to show you is there is so much of demand of solving so much of demand where people want to solve technical problems, S&T problem, and many of them are philanthropic organizations. We have enormous CSR money in the country, enormous CSR money. All these people would like to contribute to research. So what they do, they will probably buy an ambulance, which is a good thing, and do it. Now we are saying you can also do for R&D, which will influence the society in a good way. And that's what is also happening. Many international organizations have come, and 16 Center of Excellence have been established. For example, one Center of Excellence in Palghat, IIT, looks at waste, human waste, and our all the waste to energy. That is funded by, I think, Bill Gates Foundation, almost 35 crores, I guess, if I'm not wrong. They are working. So it's not government money alone. Most of it is actually private money. What we have enabled is this platform, and hand holding is done till the end, and make sure that it's a clean money, all that is done carefully. All that is done. 260 academic institutes have been supported, and 916 startups have taken the challenge. So this is really where they are working on a problem which is needed by the industry or the philanthropic organizations. All this is happening. So I thought I'll tell you, these are all our central ministries are participating, global partners are participating, and few industries I have told, there are large number, and this is what is happening. The last few minutes I want to say, because it is started by Dr. Chidambaram when he was the PSA. So I want to really give my salutations to him, because he played a very, very major role in Indian science ecosystem for almost like 60 years. And you know that one of the thing which he started was Rural Technology Action Group in our office. So what he did was, he identified 6 IITs and said, you go to the villages and find out what are their problems, and for those problems find a technology based solutions, and these solutions have to be implemented on ground and demonstrated and implemented. So this was done actually in the last few years. This was the phase 1, and this is where almost 62 technologies came out. 62, 34 of them we have made YouTubes. You can again go to YouTube, put RootArg, you will get 34 technologies which give 1 minute video, because that is your attention span. In 1 minute you will know what technology it is, and you can go to the right person. It has a contact address. This one deals with textile, water resource, agriculture, food processing, handicraft, rural entrepreneurship, livestock, and others. All these are the places where these technologies have been deployed all over the India. What we found when I started reviewing it, this is extremely good, but it is not really being done at a scale. We just don't need 10 villages. We need thousands of villages where this can go. So how do we do it? Sorry, I don't want you to read. Many technologies have come up. You can see on the phase 2 now has come up. In phase 2, we have gone beyond IITs now, and there are now 8 institutes which have posed the problems needed by the villagers, and it has been vetted, all those has been done, and they have started again on this. This is the last part of my talk. What we found, even when we are doing this, it will have still problems. Why? Look at the statistics. The technology penetration in rural India is only 2%. Only 2%. This is the report. Which means most of the technologies do not go to rural sector. How do we break this jinx is the question. So this is where we have large innovations. That's not the dearth of innovations. But they do not go to the rural area. So what we said was, these are the problems. Can we solve it, or is it an impossible problem? So what we have now done, this is the newest initiative called RUTAG Smart Village Centers. What we are going to do, all these 64 technologies which are in phase 1 and whatever comes out in phase 2, they will be positioned in physical centers around the country. There will be a local entrepreneur who will make them by hand holding with the inventor. Oh, this is my, so it says shut up. Yeah, I will just take 2 minutes. Mine. That was mine. What we want to do is these centers, but again, let me give you the fundamental idea behind it. We do not want these centers to be government centric, because once you get government money, you will have tons of restrictions. We want people who want to help us. We want people who want to devote their time and energy and resources, who can help the villagers or the laborer. So these centers will not only be doing the RUTA developed technologies, but any technology which is suitable for villages. So this is what the goal is. A role to be played within the framework based on the specialization of innovator role. This will be the innovator role, and this will be the NGO's role. So we have, everything is on the web, by the way. Everything is transparent, and everyone who wants to make this center can apply with filling the particular thing, and if they cross a threshold, they will be asked to be associated with us. It's not that anyone, because we don't want just loose players, we want very serious players. And good news is, so now we are going much beyond RUTA technologies. Villagers need much more help than just the technologies. So we are going to do agriculture services. RUTAG is one of them. Livelihood entrepreneurship and renewable energy, how we can help. In editech education for their children and them. Affordable housing, WASH, fintech, R&D intervention, government schemes. Lot of government schemes, but they don't know how to even use them. They need, they will be assistive technologies, and any other solution which villagers will need as we go along. These are the 12 verticals in which this RSVC will work. Good news is, in last 3 months alone, this is only 3-month-old idea. In 3 months, we have rolled out now 22 such centers. All 22 centers are funded for the initial cost by some philanthropy or some state government, and then there is a running one, and the person who are running can be the village Didi, or it can be a panchayat, or it can be young people who want to help the villagers. All 22 are functional now, and all 22 have rolled out agriculture services already. So what are agriculture services? Soil organic carbon mapping, they can do much cheaper. So this technology has been given to them. It's not that they think. Then we have given satellite-based soil nutrient analysis, helping with ISRO. Crop rotation, dose, satellite-based crop monitoring. All these things are rolled out, and we have put a very limited cost on each one. You want soil testing? Don't run to the city. It's just in 40-50 rupees it can be done at home in your place. These are the kits. All that we want to make each center economically independent in next 3 years. We don't want them to depend on us. So this is the model which is working. These are some of the things already working these are 2 rooms, 20 by 20 feet, 2 rooms, where this Rootag technologies will be displayed. Farmers can come and see what is good for them, and all these things have been rolled out, and many more are now coming in. And good news is that there are so many people who want to help and join us. It's not that there is a dearth of people in the country. So many people want to help with technologies. It's amazing. Actually, if you just get to know this, it's so overwhelming that so much support is there to contribute to society from the technology side. So these are the young girls from the village who are the volunteers. No volunteers, they are actually also paid for such. But all these things are actual pictures. And like, for example, Market Mirchi, a digital platform for farmers by Bombay. It was done in Rootag. Under the Rootag, it has been rolled out, and this is heavily used because you can get the right pricing for your produce. So they don't have to go to the city. So all this, I thought, connects to Vigyan Bhawan. So I told you 2 parts to my life. Vigyan, which I gave you one example of a heat engine paradigm. Other, I thought, equally exciting for me, because whatever we learn in science is actually the rational thinking. It's just that you have to just do rationally. You have to see what will work with the sensitivity of people. You have to be sensitive to what people need and what society needs. You have to do that, and these are again the pictures, again for fun's sake, created using a AI tool. So thank you very much.